So what do you all think a solution is?
A mixture of liquid.
Alright, it could be liquid, yeah.
Mixture of like elements.
Mixture of stuff, yes. And everything's made of elements, right? So yeah, mixtures of elements or matter, mixtures of matter. What are some examples that you all might think of?
Trail mix.
Trail mix, okay. Salt water, yeah.
Those like flavor packs you put into water.
Yeah, so when you put like flavor waters. Yes, and solutions don't have to be liquids or solids. What about air in the room? Is that a solution? A
Yeah.
mixture? Yes.
CO2.
Alright. Alright, so we need to talk about a term, and the term is called soluble. Okay? Soluble means something is capable of being dissolved. Alright, so I'm going to give you a table. I'm not requiring that you learn solubility rules. If this was like an AP class and you were going to take an AP test at the end, you would have to learn solubility rules, but it's not. So instead, you have a solubility chart that you can look at. We had
AP class.
and I might have given you this when we did double replacement reactions last year.
I don't think so. I literally
This looks like
Don't be rude.
Bro.
I'm gonna beat you up.
Just the letters.
We did the front side, not the back side.
Alright. So this is a general solubility chart. So obviously not everything is on here, but the main rules, whenever you consider solubility rules, those elements are on here. Alright, so when you look at this chart and it says S for soluble in the key, that means that would be capable of being dissolved in water. So I, insoluble, is not capable of being dissolved in water. So do you remember the symbols? We had S, L, G, and AQ. Which one is dissolved in water?
AQ.
AQ. So you could write AQ behind something that's aqueous, or behind something that's soluble, because that kind of means the same thing, dissolved in water. Alright, if it's insoluble, that means it's not going to be aqueous. Alright, it does not dissolve in water. So it would have to be maybe a gas, but usually a solid. So do you guys remember what the name of that is? It's one of the signs of a chemical reaction. It starts with a P.
Precipitate.
Precipitate, good Nia. So our solid is going to be our precipitate, because it is insoluble. Our aqueous is soluble. Okay, just so that we kind of relate some terms to what you already know. You knew that solids are precipitates. Well, that would be our insoluble on the chart. It does not dissolve in liquid. Aqueous would be our soluble. It does dissolve.
Where's L?
L just means liquid, like a liquid chemical.
Gotcha.
Alright, we also have slightly soluble on here, so it kind of just depends on what it's mixing with. Typically, I go with aqueous or soluble when it says slightly soluble.
Gotcha.
Alright, so here's your paper. Yes.
Is G gas?
Yes. Yep, gas. And sometimes your gas can also serve as your precipitate, even though it's not a solid, because it's not going to dissolve in that water. It starts to bubble out, so that would be something that's not soluble. So I think our gases on here are sometimes the DRs.
The decomposed.
Yes. Yeah. All right, so let's do an example. I think that's what's coming. Okay. All right, so it says Ollie is trying to test for the presence of sulfate in a solution in the lab. Use the data in the table to select which procedure she should use to test for sulfate in her solution. Uh-huh.
I have a question.
Yeah.
So you said, like, if it's insoluble, that it's like either a gas or a solid, but can't gases be dissolved? in
They can,
liquids?
yes. They can. We're gonna talk about that. So like carbonated water is an example of when gas is dissolved in liquid.
I like carbonated water.
Alright, so we want to test for the presence of sulfate. Alright, So we wanna look for a solution that would be, insoluble with sulfate. Meaning that it would not dissolve, cause if it was dissolved in there, would we see the sulfate?
No.
No, okay, so if we wanna test for it, we want it to be insoluble, we wanna see that precipitate, okay? Alright, so, think about these as double replacement reactions, double replacement. So if I took aluminum chloride and aluminum sulfate, alright? Well, my aluminum switched, I'm still gonna get the same product, so that's not really gonna change anything. In fact, all of these wouldn't change anything if we switched them. Alright, so if we found aluminum chloride, so aluminum and chloride, we match it up, that would be soluble. Alright, and then aluminum sulfate would be soluble. Are we gonna see a precipitate in that one?
No.
No. Alright, the next one. It says adding potassium chloride, so potassium chloride, soluble, to produce potassium sulfate precipitate.
That's not work.
No, both are soluble, it's not gonna do anything. Alright, next, adding lead nitrate to produce lead sulfate.
That works,
Yes, why?
because I'm just following the chart, it makes it insoluble.
Yeah, lead sulfate is insoluble, so there's gonna be your precipitate right there. Your insoluble one, the lead sulfate. So testing this, and I feel like they're adding this to something else, cause it says to produce, so they might be adding it to like lithium sulfate or something, and that's where they're switching it and they're getting the lead with the sulfate to get lead sulfate.
So like, when we take the test or something, right,
Mhm.
hypothetically speaking, is it gonna be a chart, or are
Yeah.
we just gonna have to?
No, you wouldn't have to have it
Hope and
memorized.
pray,
No, no,
okay,
no. Alright, so let's do,
it's fun.
Okay.
Oh, that's what I was saying,
yeah, totally.
mine's so sweet.
Alright. Okay, so you try it. It says Ollie is trying to test for the presence of lead in a solution in the lab. Use the data in the table to select which procedure she should use to test for lead in her solution. So look at your options. Which one would show her that she has lead?
D.
B.
I think it'd be B because, well,
I'm looking at the child problem, the only one that makes sense is D.
it's D, yeah, D's on the solid.
Cause that's the only one that says it's insoluble.
Yeah, cause look over here. Lead nitrate, lead nitrate, lead nitrate. All of your lead nitrates are soluble, but lead sulfate is insoluble. So the only one that would give her that precipitate would be D, adding zinc sulfate to produce lead sulfate. Alright. Okay, so here, Micah has 3 compounds in containers on the lab bench. They are silver chloride, calcium chloride, and magnesium carbonate. Use the data in the table to determine which compound is the most soluble. Alright, so we've got silver chloride. Alright, so let's look at our chlorides. Chlorides are soluble except for silver, so is that gonna be the most soluble?
No.
No, because it just said it's not, okay? Alright, calcium chloride, so this is a chloride. So soluble except for silver, mercury, and lead compounds. So is this one soluble?
Yes.
Yes. Let's check the others. Magnesium carbonate.
Teachers, please pardon this interruption. We need for all teaching and learning students who have not had their pictures taken as of yet, who normally leave North Hardin after 3rd period, to report to the small gym. Again, teachers, please pardon this interruption. We need for all teaching and learning students who normally leave North Hardin after 3rd period, who has not had their pictures taken yet, to report to the small gym at this time.
Alright, so magnesium carbonate. So here's a carbonate, and it says carbonates are insoluble except for groups 1A. What group is magnesium in? Is it in group 1 or 2? It's in group 2, so that doesn't count. So that means that this one would be insoluble. Alright, so which one was the most soluble?
B.
B, calcium chloride. So that's how you read these charts, okay? You kind of just go by what is the anion, and you look there, and then you read about its solubility. Or you can compare by looking at your cation to your anion and matching it up. Okay? Alright. Alright, so you try this one. It says mica has 4 compounds in containers. You got sodium carbonate, calcium sulfate, lithium chloride, and magnesium chloride. Use the data in the table to determine which compound is insoluble. Alright, so which one would be insoluble?
Hey. Because
How do you get
because
Yeah,
NH is
it's
an
on
exception
the-
for
it's on the last
CO, for
30% of the
carbonate, so
answers. So
that
look
makes
at
it
CO,
soluble.
CO3, right? That's the middle
Yeah,
one, it
yeah,
says
yeah.
insoluble, SO4, NH4, NH4 is solid, and it's Na, CO3 is insoluble.
Or should I have write
You
you
always
this?
look at Na, so like CA,
I mean,
SO4
I read
is
between
like
you guys, I wanted to
SO4,
stay on
Na,
top
it
of
says
you.
soluble except for, lead, whatever silver, and then all
Alright,
the
so let's look at sodium carbonate. So we go to carbonate. It says insoluble except for group 1A. Where's sodium? It's in group 1, right? So that means that this would be soluble. So we're looking for the most insoluble. So it's not the first one. Alright, the next one, calcium sulfate. So we look at sulfates. It says soluble except for calcium. So that one is insoluble. Alright, magnesium chloride would be soluble except for those. So that one's soluble. And lithium chloride, same thing. Soluble except for those 3 metals. So our answer there would be B. Calcium sulfate would be the insoluble one. Okay? Question on that? Alright. Okay, so you probably remember this back from Chem A, like beginning of last year sometime. Alright, but solutions, there are homogeneous, and what's the opposite of homogeneous? Heterogeneous or heterogeneous, however you want to say it. Some people say homogeneous. I say homogeneous and heterogeneous. Alright, so a homogeneous mixture is a mixture of 2 or more substances in a single phase. Alright, and the key thing about a homogeneous mixture is that it's evenly mixed throughout, so it has the same properties and composition throughout the whole thing. So like salt dissolved in water. That's a homogeneous mixture. You can't see the salt, but we could still separate them. I didn't make a new substance. It's still salt and water. Alright, I could put a lot of salt into it. I could put a little salt. And I could separating it by boiling off the water.
Teachers, please pardon
So
this
it's a
interruption.
mixture.
We are now calling for 9th through 11th grade students with the last name H, I, J, and K only. Please come to the small gym to take your pictures at this time. Again, students 9th through 11th grade, students with the last name starting with the letter H, I, J, and K only. Please come to the small gym to take your pictures at this time.
So some other homogeneous mixtures. T,
I love tea.
stainless steel. Because that's not an element. Alright, it's a mixture, but it all looks like one metal. You can't see the different parts. The air in this classroom, that's a homogeneous mixture. Alright, so it's whenever you have a mixture of different substances, but they are in a single phase. Alright, so solution components. You did this yesterday with your vocab. Your all's pictures were artist pictures. Alright, so make sure you know these definitions. The solute versus the solvent. Anyone know what the universal solvent is?
Water.
Yes, water. So the universal solvent is water. Water is known as the universal solvent, I guess, because it dissolves most things. Doesn't dissolve everything because there are insoluble substances, but it dissolves most things. So the solute is what goes into your solution that gets dissolved. The solvent is what does the dissolving. So the solute is the substance that's being dissolved. The solvent is the dissolving medium. So like I said, the universal solvent is water. So when we make solutions in the lab, every liquid chemical you use in the lab did not come to us as a liquid. They came to us as solids because they're cheaper if we buy them that way. And then we determine what concentration we want, which is what we're learning in this unit. And let's say I want it to be really heavily concentrated. I'll figure out how much solid I want, and I'll dissolve it into a specific amount of water. And that's how we get the liquid chemical. So all the chemicals in the lab have been basically dissolved into water, and that's why they're liquid chemical. They didn't come to us in liquid form, they came to us in solid form. And then we mixed them into water and made them a certain concentration. So you guys are gonna be doing that. It's one of your labs. You're gonna make a specific concentration of a chemical.
We're restocking your chemicals?
Yes.
Okay.
Alright. So solutions, we've talked about this, but they can exist as solids, liquids, and gases. It doesn't have to just be a liquid, even though that's what we typically think of. We can also have a solid solution or a gaseous solution. Alright, so some examples. Alright, if your solute was a gas and your solvent's a gas, you could have nitrogen and oxygen. Carbon dioxide and water is where you get carbonated water. Your solvent is your water, and your solute is your carbon dioxide, the gas. Alright, just water in the air. Alright, you guys are gonna start calling that a colloid here shortly. You don't know about it yet, but you will hear shortly. And so water in the air is, you have your gas dissolved into liquid. And actually, no, I said that backwards. Liquid dissolved into gas. Alright, alcohol in water. Alright, liquid. Dental amalgam, it's stuff that they use with your teeth. So that's when you have mercury, silver, and tin. And which one is the liquid?
Mercury.
Yes, mercury is the liquid dissolved into the silver and tin. Sugar water would be sugar dissolved into water. And brass. So brass is zinc and copper. So I don't know which is dissolved into which. I'm gonna go with zinc dissolved into copper because typically the color of it is the solvent. And brass is a copper color, right? So I'm gonna say that the copper is probably the solvent, the zinc is the solute.
I don't like cubes.
Doesn't what's it called? Mercury. Doesn't mercury and silver react? And like it destroys.
I just know mercury is extremely toxic. I don't know much else about it. I know we have it 5 feet that direction in a cabinet that says don't open, mercury inside.
I'll eat it.
Yeah. But it would cost like over $100,000 to get it removed. So that's why we just keep it in a cabinet.
Are you serious?
Yeah.
Why don't, wait, can't you just bring it to like the government? Like, doesn't the government have a thing?
No, like we would have to pay for them to come and get it out.
Oh, wait, we can't even open it.
Cause we used to use mercury, like mercury
Like
thermometers and stuff like that. It used to not be like.
Oh, that's right. I remember.
There's nobody that just comes and gets it for free.
I don't know.
What if we just gave it away?
Who's gonna take it?
The random homeless man down the street?
Whoa, I don't wanna kill him with mercury.
Whoa.
Alright.
Whoa.
Alright, so alloys.
That is very
Alright, so alloys are when you have solid solutions. Alright, you guys know alloys, metal. We didn't talk about it much last year because metal, chemical bonding of metals, it just makes alloys. Alright, so gold, 14 karat gold is gold and silver. 24 karat gold, so you don't ever hear of jewelry being made of 24 karat gold, and that's because it's too soft. Can't use it for jewelry. So I think like 14 karat is the highest karat you can.
Yeah, but that,
Yeah.
it like, it.
But those are alloys.
When you say soft, you mean like I can squeeze it in my hand?
Alright, so it says in an alloy, how can you determine the solvent and the solute? So for example, 14 karat gold. Well, typically the more, the one that it has more of is the solvent. So that's gonna be your gold. And then whatever else it has, because we know that it's not pure gold, alright? So there's silver in there, there's some copper, which is why after a long time it can turn that greenish color. If you don't keep it clean, that's why you have to clean it. That's that copper coming out. So those would be your salutes. Alright, and I feel like this is a good stopping point. What do you guys think?
I agree, I
Okay,
think.
so we will continue from here tomorrow.
So